is Mr. Reese here talking about Algebra 2, Section 4.5. Today the topic is square roots. We're going to use square roots to solve and simplify things. So we're going to build up to solving. We're going to start with simplifying, build up to solving. There's a lot of different kinds of solving. Today we're focused on square roots. We're going to divide this lesson into two parts. One is where we add, subtract, multiply, and divide radicals, and the second part is where we actually use that to solve. So we'll get right to it here. For simplifying radicals, probably an Algebra 1 topic. When we go through here, we're going to take a problem like square root of 24. We're going to break it down into its component parts. We pick 4 and 6 rather than 8 and 3 or 12 and 2. We pick 4 and 6 because 4 you can take the square root of. So you got that, 2 radical 6, final answer. So there we go, breaking down a radical. We're going to use that a lot because when we see something like this, radical 50 times radical 8 or plus radical 18, you can't just add them together. Some people want to add it and say it's radical 68. Can't do that. You got to break each of them down. So we're going to take 50 and break it down into 25 and 2, break 18 down. You'll notice these two first numbers can be taken the square root of easily. So we go ahead and do that. Now we have like terms, or what we call like radicals, and we go ahead and add the 5 and the 3 to make 8 radical 2. So you can only add if you have like radicals, and sometimes you have to do some work to get there. Now in subtracting, same thing. So here we have like radicals. We'll go ahead and subtract. Boom, problem's over. Move on. Next one. You see this one, you don't have like radicals and you can't even do anything. You can't get there. So we'll just have to leave it and we'll say nothing can be combined. So we're done on that problem. Multiplying radicals. All right, so we're dealing with monomials. So that's a monomial and that's a monomial. If you see a binomial or a polynomial, those are separated by addition and subtraction signs. We don't have any of those here. So that makes this easy actually. All you do is multiply the numbers out in front and then multiply the radicals. So 5 times 4 is 20, 6 times 8 is 18, 6 times 3 is 18. And then go ahead and break down the radical 18. And you say, all right, if I was going to try to do this, 18 breaks down into 9 and 2. Square root of 9 is 3. And notice this multiplication sign is because there was really a multiplication sign all the way through the problem. It just carries kind of through all the way through the problem. And so at the end, we have 60 radical 2. So there's our final answer on this one. All right, now we're going to deal with binomials. Well, binomials are a little bit different. When you see a binomial, it's because you have these addition or subtraction signs. So we're going to distribute. In other words, FOIL. So we just go ahead and multiply this out. 5 times 3 and 5 times radical 2 and radical 2 times 3 and radical 2 times radical 2, and we get all these terms. Go ahead and combine what we can combine and simplify this radical. So we get there. You notice that radical 4 turns into 2, and then 15 minus 2 is 13. So there's our final answer. So it's the foiling problem if you have a binomial. We'll move forward here, dividing radicals. All right, so when you divide, you may see a monomial, meaning one term, or a binomial on the bottom, meaning 2. We don't want an irrational number in the denominator, so we call this rationalizing the denominator. You see that as a direction sometimes. So as we kind of go through here, rationalizing the denominator, it's not okay to have this on the bottom, so we're going to go ahead and multiply by radical 2. Now some people say, well, I would just multiply by radical 8. Well, that's okay, but it's actually more work. When you multiply by radical 2, the idea is you get something that you can take the perfect square of. So square root of 16 is 4. Now we're done here. If you would have done this, radical 8 times radical 8, you got radical 64. There would have been more simplification to do. You can go ahead and try that if you'd like, but the idea is you can't have a radical on the bottom. You can have one on the top, but not one on the bottom. All right, let's try binomial. So when we're doing binomials here, there's a special thing that's called the conjugate. So that's a new term here. All the conjugate is the sign is switched in the middle. So when we deal with this, 5 minus the radical 2 is the conjugate of 5 plus the radical 2. And so we're going to use that to multiply. So when we got these here, now we're going to have to basically distribute or FOIL. So 6 times 5 and 6 times the radical. 5 times 5, 5 times 2, 2 times 5, 2 times 2. We get all these terms here. We go ahead and notice that, hey, you know what's nice? Those two terms cancel each other out. So our radicals are getting out of the denominator, which is the idea. Also notice that that 4 turns into 2. So it's sweet. So at the end here we have no radical in the denominator. Radical in the top's fine. Radical in the bottom's not fine. Part 2 is a lot shorter here. We're going to use our radicals to solve. So one thing about radicals is you can only do this when x is listed once. So we've seen here, we've highlighted in each example that, hey, you know what? X just appears once in each problem. That means it's the radical problem. We'll do each of these separately. So pretend as if this squared isn't here for a second. What would you do? Well, you'd isolate that term. You'd subtract off 18 and divide by 3. You just get that x squared by itself. At this point, we want to go ahead and take the square root of each side, and the square root will eliminate the exponent. So we'll go ahead and do that to each side. And the thing that you got to be careful about here is when you deal with this, it's true that the square root of something squared is a positive version. So we indicate that positive version with an absolute value. We already know how to drop absolute value bars, drop the bars, add plus or minus, and we've got our answer here. So our answer is, there's two answers, plus 4 and also minus 4. Both answers work. When we do the other problem here, the last example, do the same thing. We're going to go ahead and isolate that x squared term. So subtract 5 and divide by 2. Those are the first two steps. To get rid of the exponent, we're going to go ahead and use a square root. So we take the square root of both sides to eliminate the exponent. Again, when we deal with this, we're having absolute value bars, which some people find strange, but it is the truth. Drop the bars, add plus or minus, and then we're going to go ahead and split this into two separate problems. We can solve each one of them. So sometimes people show these arrows of there's one problem, there's another problem. Anyways, we've got two answers, x equals 5 and x equals 1. So two answers to these kinds of problems. That's about it. You should be able to add, subtract, multiply, and divide radicals, multiply monomials and binomials, and at the end solve equations by taking square roots. Thanks. Have a good one.